This function here with a and b in it has three constraints: at x is equal to 3, when y is equal to 1, and also the gradient is -1/8. And so substituting x is equal to 3 and y is equal to 1 into that equation, we'll get 1 is equal to a over the root of 1 plus 3b. And rearranging this so there are no denominators, we'll get the value for a. Now I would like to rearrange it so that the a is on the left-hand side. And so I found a in terms of b. I have two unknowns. I will need another equation so that I can work out what the a and the b is. And to do that, I'm going to make use of the fact that I know that the gradient is -1/8. So that'll mean that I want to differentiate my function so that I can find the gradient function, which in turn I'll equate it with the gradient of -1/8. And I'll rewrite my function over here, but before I start differentiating, I want to rearrange this. And now I will be able to differentiate it using the chain rule. And this, of course, could be better written down if I consolidate all these numbers. Well, it looks slightly better, but I'm still not entirely happy with this. I don't like the idea that I've got it to the exponential of 3 on 2. So please let me remind you that if I have an x and I have it to the power of 3 on 2, that's the same thing as saying x root x. This means that I can now rewrite this as minus ab over 2, and then I'll say a1 plus bx and the root of 1 plus bx. So if I rewrite this again with a's and b's, I still have the constants a and b, but I know that my gradient is supposed to be -1/8. Helps. Also, I know that I have x is equal to 3. So wherever I've got x, I'm going to change it to 3. Okay, now there's a saying that all roads lead to Rome, and in this case in maths, it's the same thing. There are many, many ways of you can get to a particular destination. I have decided to go this way, but you may have just as well decided to start with looking at your differential function first and then changing it. So we'll just go the way that I'm doing it. As long as you're doing everything mathematically correct, you should be able to get that. So I'm seeing over here that I have already found a above over here. So I think I might actually move that a into my a's here. So that will mean that I have minus a, which is root 1 plus 3b. There's also a b up here. And I will now divide this by the denominator, which is 1 plus 3b, multiplied by 1 plus 3b, the root of 1 plus 3b, and that's all equal to -8. And I hope that you can see that in this form, I have this numerator, and in here in the denominator, two things that I can cross out. And this means that I can now find the value of b, because there's only b in this equation. I'll cross multiply, the minuses will disappear, and all I'm left with is a b, or an 8b should I say, 8b, which is equal to 1 plus 3b on this side. Cross multiplied it all. I need to expand this so that I shall be able to find out what actually b is. And after tidying all up, I find that b is equal to 1. Okay, to find out what a is, I need to go up to a again and rewrite this. A is equal to, but b is equal to 1, so a now will be equal to 1 plus 3, which is equal to the root of 4, which is equal to 2. And thus we were able to find our constants a and b. You might have done it slightly differently, but if you got that answer, you were on the right track. And if you find this useful, then please subscribe to my channel and give it a tick.